Okay, rational expressions assessment review. Okay, now we see what we have here: bunch of rational expressions. It's what when you have fractions with variables on the bottom. That's what that's going to stand for. And we have to perform the operation, and it says times. Okay, well, the operation's times. I need to extend the line, and I make 3 of my own line. And I'll be doing that on this too. On number 2 as well, but number 2 is a lot different than number 1. Okay, now here's why. These are 2 terms separated by minus. You put parentheses around those. Plus, you put parentheses, minus, parentheses, plus, because those are polynomials. They're 2 terms. If there are 3 terms, you parenthesize the 3 terms. These are all 2. Now, the reason we parenthesize those is because we need to factor those into simplest form. Okay, so x second minus 4, I see if I can factor that, and that's 2 terms, so I would check for a GCF, and then I would see if I have the difference of perfect squares. Okay, so I don't have the x in back, no negative, 1 and 4 is 1, so don't do that. Now this is a difference, because you have minuses here, and 1's a perfect square because that's 1 times 1, and then x to the second's x times x, and then 4 is 2 times 2. So we rewrite that as 1x plus 2 and 1x minus 2. Take the 1's off the front of your x, and you have x plus 2 times x minus 2. So we replace this expression with x plus 2 times x minus 2. Okay, then x plus 1. So that's 2 terms again. So GCF and dots. Okay, so there's no x, there's no negative, and then 1, so we would not do that. Now we have the plus sign, so that's a no, and so that's a prime expression, meaning it cannot be factored. Okay, so x plus 1 will just remain in the same form that it already is. Again, this was replaced with this was replaced with this. Factoring means you're essentially unmultiplying the product. These are the products, you're unmultiplying them into the factors. X second minus 1. Okay, so it's 2 terms, so that would be the greatest common factor. Then I would see if we have a difference of perfect squares. Okay, so no negative, or no x at the end, so it's just 1. You have a minus, and then 1 is 1 times 1, and then x to the second power is x times x, and then 1 is 1 times 1. So that is a difference of squares. However odd it may look, it is. Okay, 1x, 1x, and then 1, 1. So you take the 1's off the front of your x's, and you have x plus 1 times x minus 1. Now, again, so this is replaced with this. So x plus 1 times x minus 1. Okay, now we also have this expression, x to the second power plus 2x. So it's 2 terms, so it would be GCF, and then dots. Now we are going to do the GCF because we have an x at the end. No negative, 1 and 2 is 1, but it's 1x, so we need to go up here and divide by 1x. So that's 1x plus 2, and then the x's wipe out. Now, when you do the GCF, you bring it down. We're going to bring that down as an outer factor. Okay, that's a plus, so it can't be a dot, so you know right away. So you bring down 1x plus 2. Now take the 1's off the front of both the x's whenever you have a 1 coefficient, which shouldn't be there. So you replace this with this. So this is crossed out and replaced with x times x plus 2. So what parentheses can we get rid of? Well, the x plus 2 we can get rid of. Not the x minus 2, the x plus 1 can go away. So these 2 parentheses will remain at the end of my answer. Okay. Now, what do we have for outer factors? Well, we don't have an outer factor on top, but we have this x right there on the bottom. So I put x on the bottom. So since there's nothing on top with it, it cannot possibly simplify, so I just drop it on the bottom here. That's your answer. Okay, number 2 is another multiplication problem, but it's not nearly as tedious because that's only one term, so we cross that out and bring it over if I recognize it as only one term, because there's no plus or minus in it. Nothing in there either. So 5y to the third. Top, bottom, same thing, okay? I mean, those are not plus or minus expressions, so they're only one term. They're monomials. Okay, so there's no parentheses like you had here. You won't be crossing out any parentheses. You will not be putting any in your answer, but there's a matter of simplifying the outer factors. So I have a bunch of outer factors there, 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 and there. So you need to multiply the tops. 2 times 5 is 10, and then x to the fourth and y to the third are two different variables, so I just keep them separated. Now bottom here we take the 10 times the 4, and that's 40. And then y to the second and x to the third are two different variables, so they remain separated. Now you have to simplify from here to here, okay? So 10 over 40, you need to divide those by their GCF, okay? So 10 and 40 have a GCF of 10. So I'll be dividing 10 by 10 to get 1, and 40 divided by 10 is 4, so it's 1/4. Then we have the x to the fourth and the x third, so we cancel out the smaller one, subtract 3, and that would be x to the first on top, or just x. y3 and y second, okay, minus 2, and 3 minus 2 is 1, so y on top. Okay, you can put the 1 powers, not really needed. Okay, now in the next problem we have equation to solve. That means I'm solving for x, finding what the variable x would equal. Now it's in a proportion, and you just have one ratio on each side, so I want to apply the cross product method, which is the easier of the two methods that exist. Okay, so I know that taking x minus 1 times 4, the AB product, is equal to the CD product. So I set up parentheses, I said product, so that's multiplication. So A times B is going to equal C times D. So A is x minus 1 and B is 4. C is x, D is 6. Now on this side, we just distribute x to 6, that's 6x. Now over on this side, we have to distribute, there's a minus sign, so like a plus sign, we have to distribute 4 across a minus. So x times 4 is 4x, and negative 1 times 4 is negative 4. You're more than welcome to put a plus negative there too, and write plus negative 4. So now that the parentheses have been simplified, I think there's only one answer for that. I keep this at the solution set at one answer because I just have x. I don't have x to any powers, okay? That's all you got. So you're going to apply your linear properties to this, okay? So linear property is where you get the x by itself. Well, if there's an x on opposite sides, you can't really get x by itself, so you take out one of the x's. It would make most sense to take that out. Just get the x's to one side of the equation. So it's 2x, and now linear properties means you highlight the operations and do the opposite of the operations, divide by 2. So negative 2 equals x. Okay, now the next problem I'm solving another equation, 2 over x plus 3 plus negative 5 over x minus 3 equals 6 over x to the second power minus 9. So I'm solving for x here. But I can't use cross products because you have 3 ratios, including one side where you have addition. So you will need to apply the common denominator method, and that's when you extend the lines, make 3 big lines, that plus goes down, equals goes down. And the tops, okay, you just drop them. Okay, or first off, put in parentheses where needed, so nothing on top. That gets a parentheses, and that one does, because there's plus and there's minus, and then there's minus, so that one. Now the tops you just drop, regardless as if they have parentheses or not. Even if they do, they don't have to be factored. Now, before I write my bottoms, I need to see what can factor. So, I mean, x plus 3 is a binomial. It's got two terms. So it'd be GCF and then DOPS. So GCF is 1, and a plus can't be a DOPS. So that expression is prime. X minus 3. So GCF and DOPS. So DOPS means difference of perfect squares. So there's no x, there's no negative, 1 and 3 is 1. Now DOPS, you might have a minus, and 1 might be 1 times 1, but the x doesn't have a power. Okay, and even if it did, 3 is not a perfect square. So that's no, so that is a prime expression. Okay, then x to the second power minus 9. This can be a little bit different. Okay, so there's two terms. So that would be GCF. And then you would see if you have a difference of perfect squares. So GCF is 1 again. So you have a minus, and that's true. 1 times 1, x seconds xx, so 1x times 1x is 1x second. Add minus, and then 3 times 3. All right, so 1x, 1x, and then 3 times 3. So we do factor this into x plus 3, x minus 3. So you replace this with x plus, so you replace this with this. Now we are ready to find the common denominator. So when I look at my bottoms, I have a parentheses factor of x plus 3, a parentheses factor of x minus 3, then more of the same that I've already written. So x plus 3, I have 1, 0, 1. So we need to get this one here in the middle, a factor of x plus 3. And then when I bring it in on my own, I'm allowed to do that as long as I multiply it on top. Remember, a fraction maintains its equivalence. If what you multiply on bottom, you multiply on top. Okay, x minus 3. I have 0, 1, 1. Get this to 1. Okay, so there, cross them out. Now you line up your equals, and you go parentheses plus parentheses, and then parentheses. Now you shouldn't really need the math papa for this. I mean, that's 2x, and that's negative 6. Same here, that's negative 5x and negative 13. And right there is just a 6, okay? So I would condense my equation so that I have 6 on this side. This side we have to simplify, okay, with the plus. That's when you draw your spaces. You have x constant, x and constant. So x constant. So 2 plus negative 5 is negative 3. Negative 6 plus negative 13 is negative, it's not negative 13, it's negative 15. I'm an idiot, okay? Negative 5 times 3 is negative 15. Negative 6 plus negative 15 is going to give me negative 21. Okay, now I keep the solution set at 1 because all I have is x. Okay, so again, linear properties. Now this is even easier because we have x on one side. We just got to highlight the operations. You got times and negatives, so you add 21. 6 plus 21 is 27. And then you divide by negative 3, and 27 divided by negative 3 is negative 9. Okay, well, it's kind of easy one at the end of it, after all is said and done. Okay, next one. I currently have scored 140 of 200 points in a class. How many consecutive points must I acquire to raise my grade to an 80%, okay, without missing any? So, this is an average problem. Okay, it might not say average, but that's what the percent is an average. Okay, so you go right into your proportions, and your percent needs to be 80. That's over 100%. Okay, so we scored 140 of 200. That's at a 70%. Okay, so I want to add to my points, and then I need to add to the bottom, because if I get my next 10 points, that's 150, but then that's out of 210 then. So whatever you add to the top, you have to add to the bottom. So that's going to be cross products to solve it, because you have an equals, just one ratio on each side. There's no adding in between the ratios. So again, I know that the AB product, this is A, this is B, is equal to the CD product. So A times B, and then C times D. So A is 140 plus X, and then B is 100. C is 80, and then C is 200 plus X. Okay, so you got your plus sign, so you need to distribute, obviously. Okay, 100 times X, 100 times 140. 100 times 140 is 14,000. And then 100 times X would be 100X. Okay, over here you have that plus sign. That means you have to just multiply two products. 80 times 200, okay, it's going to be 16,000. Then 80 times X is 80X. Times, 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 times. Okay, so you're solving for X, and again, all you have is X, so that's linear properties again. So you get the X by itself. You have to clear an X, not the whole side, just an X out of one side, so you get the X's on one side. You're not going to clear that because you want these other ones to come over here. Okay, so it's 16,000, okay. So you have 20X plus 14,000. Okay, then multiplication, so then you minus 14,000. That's 2,000. Then 20 times X. And you divide by 20. Divide by 20, that's going to be 100, okay. So he's got to get his, so if there's another test that has 100 points, he's got to get all 100 of them to achieve his goal. Okay, on a trip, 2 planes travel for the same amount of time, okay. One plane travels 1,600 miles while the other plane travels 1,400 miles. If one plane travels an average of 20 miles per hour faster than the other, for how many hours do the planes travel? Okay. All right, so this is a dirt problem, because distance, rate, time need to be kind of taken into account here. Okay, so that's what a dirt table looks like. You got distance, rate. If you're wondering what rate is, it's always whatever you have as your per, the speed, and then the time. So we have plane 1 and plane 2. Okay, so the distance is given, 1,600 for plane 1, 1,400 for plane 2. Okay, now the rate, 20 miles per hour, but it says faster, so that means that's plus 20. So the one that went the further distance would be the faster rate. So it's R plus 20, and this would be R. Now the times traveled. We know that the times traveled are equal. We know this because it says they traveled for the same amount of time. That means equal. We also know that the time can be expressed as the distance divided by the rate. So the distance is 1,600. I can't really divide because the rate is an expression, has an unknown variable. And 1,400 over R. So we set those equal to each other. 1,600 over R plus 20 equals 1,400 over R. So I'm solving for R. There's one ratio on each side of the equation, so that sets me up perfectly to define my cross products to solve. Okay. So the AB product going this way is equal. The diagonal products are equal. Okay, so I'll be taking A times B, C times D. So A is 1,600, and then B is R. C is 1,400, and then D is R plus 20. Okay, that's just one product, 1,600 R. This time, since there's a plus, that is two products, so we have to take 1,400 times R and 1,400 times 20. Okay, so it's going to be 28,000. Now, your R is only to the first power. Okay, so you're going to, again, use your linear properties to solve. Okay, now you get the letters, the R's by themselves, okay, or the R's need to come to one side, the non-R's need to come to the other side, or need to be lined up on the other side. So I have an R on both sides. You mark whatever one you want to get rid of. You don't clear one side. That's not how linear properties work. So 200R equals 28,000. So you divide both sides by 200. That's going to be 140. Now, you're like, well, that's kind of a high rate. Well, it's an airplane. It does go pretty fast. That's kind of the purpose of taking a plane. That's actually even slow for an airplane, okay? All right, so the rates, that's not what you're finding, but you come here to your time. Now that you know R is 140, okay? 1,400 divided by 140 is 10, okay? That's my answer. If you want to check it, you add 140 plus 20, that'd be 160. 1,600 divided by 160 is also 10, okay? These should be equal. Okay, number 7. Two pumps going at the same time can fill a 40-gallon bucket in 5 minutes. If one pump can fill twice as fast as the other, how long would it take each pump to fill the bucket separately? So the minutes, two answers. Now, it's not a dirt, not an average problem. Okay, so gallons and minutes would be the rate units you need to analyze, unit analysis. X is minutes, Y is gallons. So per. Gallons per minute. Gallons per minute, we do not have that. Okay, I could easily find it. It's 8. 40 divided by 5 is 8, but I'm not really going to need the exact rate of change, because given the fact that X is minutes, Y is gallons, and pretty sure that so we have 5 minutes, 40 gallons. Pretty sure if I work for 0 minutes, I'd have 0 gallons. So I'm going to use a proportion. So that means I really don't need the 8 gallons per minute. Okay. Okay, so you got the together amount here, and this side's your separate amount. So since there's two different buckets, we need two ratios added together. Okay. Now it's gallons per minute, so it's got to be gallons over minutes. Gal, min, gal, min, gal, min. So together these dudes can do 40 gallons in 5 minutes. Okay, we know that. Separate, they would still need to fill 40 gallons. We just are finding the time it takes. Okay, but we do have this fact that one fills twice as fast as the other. So twice means times 2, not plus 2, okay? So that means X times 2, and this would be just X. Now we can't use our cross product method to solve it because there's 3 ratios, including one that's being added. So we have to apply the common denominator method. Okay, where do I need parentheses? Nowhere. Certainly not above the 40s. That one people might put in parentheses, but that would be incorrect because that's only one term. There's no plus or minus, so X times 2. You can also write 2X if you really want. Then X, and then 5. Common denominator, you have outer X, no parentheses, 2, another outer X, I already have a category for that, and then 5. So outer X, 1, 1, 0. When you need, this one needs an outer X. 2, 1, 0, 0. So these last two need that 2. 5, 0, 0, 1. So these first two need that 5. Okay, now the denominators are all the same. The denominators would be 10x, but the denominators, once they're set equal, that's now when we can find the products on every fraction, okay, and solve it. Okay, so 5 times 40 is 200. 5 times 2 is 10. 10 times 40 is 400. And over here you're going to have 80. 80 times x is 80x. Okay, so you have 80x, and over here you got it simplified. Those are both constants. You just add them. Okay, so I'm solving for x, and all you have is x. There's no x. That variable is not to any power or anything, so that's an automatic linear properties problem. So you got multiplication, and you just go divide by 80. So 600 divided by 80 is 7.5. So those 7.5 minutes right there. So this guy would take 7.5 minutes because that's the x value. Now this other dude would take 7.5 times 2. So you multiply that by 2 and 15. The time you find first is actually the guy who can do it faster. Okay? Don't divide it by 2. Okay, and then the last one. To save time, a man took a small airplane to get a lunch. Get to a lunch meet, I guess that's right, and then return home. The plane flew a total of 4 hours, and each way the trip was 200 miles. What was the speed of the wind that affected the plane, which flies at a rate of 120 miles per hour with no wind? Okay, so the distance you have to travel, distance, speed, time. Speed is like rate, it's just another term for rate. There, back, total. So when he goes there, he's going 200 miles. When he comes back, obviously the same thing. Then you add, you get 400. Okay, now the speed, 120 miles per hour. Okay, that's fine. But there's wind. There's the wind part. Okay, so when he goes there, if he's flying with the wind, he'd add x. Against the wind, he'd subtract x. Now it doesn't matter which one's which because they both are 200 miles. So that's not going to really be a big deal. Alright, so the time is 4 hours, so we have to fill out the equation that equals 4. Well, time is the distance divided by this rate. In this case, it's distance divided by speed. Distance divided by rate, distance divided by speed mean the same thing. So you put your 200 over 120 plus x, plus your 200 over 120 minus x. And there's your equation. Now I'm going to put that 4 as a ratio. I'm not going to put a 1 under it because I'm not going to be able to do the cross products because you got plus and you got 3 ratios. So you have to use your common denominator method. Tops would not go in parentheses, these would, because there's a plus, there's a minus. So the tops I drop, even again, I'm going to emphasize that point again, even if the tops do have a polynomial, if there are more than one term, you do not try to factor the tops when trying to find the common denominator, because it's all about the common denominator. Now the denominators cannot be factored, okay? I mean, you can try 120 plus x. Actually, see, if you would try to factor like this one, I'm going to show you this. 120 minus x. First off, it's written in the improper order. Okay, it's really negative at 1x plus 120. I write it like that in the story problem because it makes more sense. But if you factor it, you have to write it so the x comes before the constant. Then, GCF, I guess you could do negative 1, okay, negative 1x, okay, negative 1. Now don't do this, just watch. Do not write this down. Don't write this down, okay? So negative 1, okay? So it's going to be positive 1x minus 120. That's not a DOPS, okay? So there's no way that is. Now, I mean, you could do it that way, but it doesn't really help us all that much, okay, to be honest with you. So don't, just leave those, okay? Just leave those in the form that they're in. Not even sure why I did that on the paper. So again, these will keep their form. I mean, the GCF, yeah, that's 1. That would technically be -1. But again, I mean, if I did a -1 and an x minus 120, I guess it would kind of overcomplicate the problem on this one. So common denominator, you got 120 plus x. Then we got 120 minus x. So plus x, 1, 0, 0. So these two need the 120 plus x. And so does that one. Okay, 120 minus x, 0, 1, and 0. Okay. That one already has it, 120 minus x, 120 minus x. Okay, now the denominators are all set. Okay, so we line up the equals, same we do as we normally do. Okay, so in the first one, that's where I'm finding what that would multiply to. Negative 200x plus 24,000. Makes sense because that'd be negative 200x, 24,000. Then over here, 200, and then just switch that over to a plus. 200x plus 24,000. Now on the other side, you take your 4 multiplied by 120 plus x, and then 120 minus x. Okay, negative 4x to the second plus 57,600. Okay, so over here you have the negative 4x squared plus 57,600. Over here, okay, you combine your x's and constants. Negative 200 plus 200 is 0. Get that out of there. 24,000 plus 24,000 is going to be 48,000. So now that's my equation. Now I'm solving for x. Okay, we have x to the second. X is second's all you have, so you add a second answer into your solution group. Okay, because of the second power. But it's x second only. That's the only type I have. So I'm using linear properties just like I would with if there's just x, but then I have to apply a square root at the end to get rid of the second power. So we have a times and a plus. So we minus 57,600. Okay, so it's going to be negative 9,600. And that's going to be negative 4 times x to the second. So then we divide by negative 4. And you take negative 9,600 divided by negative 4. 2,400. Now you apply the square root. Okay, it's definitely a even root, so it's positive negative. Okay, so you go 2 second caret 2 second, key next is 7. I'm hitting the wrong button, okay. And I get 40, I'm just going to go 49, okay. So, positive 49, negative 49, but of course positive 49 is the legit answer. It's kind of windy day. Gus,